Seeking English S.A.T. Workbook, page 378, problem 2, no calculator. I need to put these answers on the board because if you prefer a different formulation, that's too bad. You're going to have to pick among these four formulations at the end of the process, and I need everyone seeing this video to see that, whether they have a book handy or not. This problem, I'm going to make it look pretty simple, but students are very confused by it. So don't tell yourself that you don't need to see the video a second time if you do need to see it a second time. Watch it as many times as you need to. Make sure that you understand this problem, because this is an important problem in spite of how simple I'm probably going to make it look. It says, after eating dinner at a restaurant, N friends agree to split the total bill of D dollars equally. If K of the friends don't contribute, which of the following represents the additional amount? Which represents the additional amount that each of the remaining friends must pay? At this point, I want to stress again, as I think I stressed in my very first math video, that you need to tell yourself the correct story. You need to at least slow down long enough to make sure that you do that to some degree of confidence. If you want 99% on the test, you need to be 99% confident. If you only need 80% on the test, 80% confident. It's a question of what score you want on the test, but you need to slow down to make sure that you are sufficiently confident in how you're telling yourself the correct story. Because if you're not going to bother to do that, if you're going to rush telling yourself the story, then you're kind of wasting your time, and you could be using that. You could just guess on this question and use that time on the next question. I know it sounds cynical, but it's the truth. If you think about it that way, okay, just decide what your level of commitment is to getting the correct answer. If it's 99%, great. You're with me. Okay, let's start. You want to do is, in this case, we're looking for a difference of two amounts, a larger amount and a smaller amount. The larger amount is what people paid for dinner when some people did not contribute, and the smaller amount is what they would have paid for dinner if everyone had contributed. So this may not look like the correct story for you, because part of it is in preterite and part of it is in counterfactual past conditional. Don't worry about that. It's not a grammar class. Let's start with the story here. The amount that they paid is the larger amount, so I'm going to put that on the left. Not because it's something that in the story actually happened, but because it's the larger amount, and I want to subtract the smaller amount from that in order to get the difference. Okay, and I'm going to subtract the smaller amount from that. What they have in common is the numerator. Okay, there's no difference in the numerators, so instead of these fractions being different in terms of one of them being top heavy, they're going to be different in terms of being bottom heavy. Okay, the one that has the smaller, you'll see what I'm talking about. The smaller the numerator, the smaller the denominator, the larger is the real value of the fraction. Okay, the larger the denominator, the smaller is the real value of the fraction. Here, I'll start by making these look similar. Okay, here's the same story told twice, and I'm going to modify one version of these. Okay, this is what dinner cost, and this is the number of friends who divided it. This is what dinner cost, the number of friends who divided it, except that what you have to contribute if you're one of these people goes up. The price increases if some people decide not to pay. Okay, the increase is going to be over here in the larger amount. So N minus K. K friends out of N did not pay. So this smaller denominator causes the value of the numerator to increase compared to this other one. Am I over-explaining this? Maybe it's worth over-explaining once. Okay. So that's the larger amount. This is the smaller amount. Now, to get it down to one fraction, because you see each of these options is a single fraction. So if you don't know anything else about the problem, you at least know that. You need to get both of these things into a single fraction. How can you do that? Your instinct may be to try to get rid of one of these denominators. Okay? So if you got rid of the n, then you'd have this denominator, that denominator. If you got rid of this denominator, then you have this denominator. That would be really convenient if you could get rid of that. That's it. No, I'm telling you, it's not that convenient. I don't want to give you a spoiler here, but let's pretend that we're going to deal with that part of the problem after we at least get these into some kind of a fraction form. Okay? Single fraction. I'm going to put them both over one denominator. The simplest shortcut to doing that normally is this. You take this denominator and multiply it by both of these things over here. And you take this denominator and you multiply it by both of these things over here. Okay? So I'll take this n first. It's easier. It's going to be n times n minus k, and this is going to be dn. This is going to become, d times n minus k, okay, over n times n minus k. You say, but that doesn't simplify it. No, it doesn't simplify these fractions. It makes them worse. But if you're going to try to make them one fraction, you need to desimplify them momentarily, okay? Now that we have two fractions with the same denominator, it's gonna look sloppy, but I'm gonna do it like this, at least for the moment, okay? Put them both over the same denominator because that is what they have. So now all this junk, you can worry about that after you have produced one fraction of some kind. From there, it's a little bit messy, but at least we have something. Again, if you're looking for spoilers, you're going to find them. Please don't look. Okay, if you're watching this video with somebody else, don't spoil it for them. Okay, from there, again, multiplication. We don't think of it as something that simplifies things, but sometimes it is. In this case, it did simplify. It turned it into one fraction. It's going to simplify again in a second. I'm going to take this and multiply it both by this. I'm going to distribute this d to this n, this minus k. Be careful because of the two negatives. The dn is a negative, okay? But the minus becomes a plus here. It becomes dk, okay? How does that simplify it? Well, if it doesn't look simpler to you already, it will in a moment. Look at anything you could eliminate from the numerator. That's dn minus dn, that's 0. Okay? And what's left there, once those dn's cancel, is the dk. Okay? So how much further do we have to go? Well, we don't have to go much further. You get to a point where what you have matches one of the answers. Stop. Absolutely stop there. And I've seen students not do this, not with this problem, but with other problems. So it could potentially happen with this problem where they sit and stare at this, trying to reduce it further, not realizing that, yeah, it's this one over here. Okay. Like I said, I think that this video for a lot of students is probably worth watching twice, in spite of the fact that it's getting pretty long here. Maybe I've over-explained it and made it seem simpler and easier than it really is by stretching out the explanation. But I've seen students really struggle with this problem. So if you can get this completely internalized, memorized, as a model for similar problems on the test, it's going to help you a lot. And you might be very surprised how similar in structure a problem is, or how similar is the process of getting from where they start you to where you need to end. I'm often surprised how similar things are.